Okay, boys and girls, we're starting a new lesson today and a new topic, topic 5. We're going to be learning how to write equations and solve them. So we're starting right off the bat here with the word problem. I know it's our favorite. And it says, a farmer ships apples in crates that weigh 4.2 pounds each when empty. That's important. And each apple weighs 0.29 pounds. Okay, so the total weight of a crate filled with apples, total weight is 50.6 pounds. Write a word equation that you could use to find the number of apples packed in each crate. So we have to think about that. We know the total weight, we know the weight of each apple, and we know the weight of each crate when it's empty. So I'm thinking my own way through this. If we want to know how much each apple weighs, then we would have to multiply it. We would have to multiply this number, this 0.29 pounds, times a variable, something like this, 0.29x. That would be the total weight of the apples. This would be all the apples. And how much the crates weigh, plus, if we go backwards, it's okay, 4.2. So that's the weight of the crates. These are the crates. These are the apples. Okay, so if I change the color of my pen and I go like this is the weight of the crate, this is the weight of the apples, and it's going to equal how much? I'll write it down here, 50.6. So if I take the total weight of the crate, total weight of the apples. Okay, so let's just figure out which words match this. So you can see that they all start with this word, total weight. Total weight, total weight, total weight, total weight, equals. So they're identical up to that point, all the same. And even more, this is the weight of the crate, the weight of the crate, weight of the crate. So where are the differences? Okay, well, here we start seeing some, let's see. It's just a question of, the next thing is times there, and then minus, plus, times, plus. So we got to figure out what we're doing. Okay, is a total weight, let's read through the first answer. Is a total weight the weight of the crate times the weight of one apple plus the number of apples? Is that what we're doing right there where I just put that point? Right here, I'm going to put a little star. I'm going to change my color. I'm going to put a little star right there. What are we doing right there? Are we multiplying? Are we adding, subtracting? What are we doing? Okay, so, and first of all, what are we doing right here? Okay, so that's going to be, that has to match this. Okay, we're adding to the weight of the crate, right? So which one has to, it has to be either C or E, because we're adding to the weight of the crate. It can't be B, we're not subtracting. It can't be D, we're not multiplying. Okay, so, and it can't be A, we're not multiplying. So let's look at C. Is it the weight of the crate plus the weight of one apple times the number of apples? Is it the weight of one apple times the number of apples? Yes. That's exactly what we just said, right? And just to double check, E says the weight of one apple plus the number of apples. No, that's not what we're doing right here. We're not adding right there. We're multiplying that 0.29 times x. So the answer is, what did we say? C. Right there, C. Okay, well, that last problem was not too hard. You just had to read through it, think your way through it. Here we have another problem that says, write an equation to represent the following description. So we're going backwards now. It's giving us all of the words, and we have to think of how to represent that with numbers and letters and such. So let's read through it very carefully. It says 17 more than. That means 17 more than something. And what is that something? That something is 3 times a number. Okay? And then we say the is, those words right there, is, that's the equal sign. So, and everything is 2. So 2 goes on that side of the equal sign, or the other side, doesn't matter. But whatever it is in red, the underlined parts, that all has to equal 2. So that is 2. Okay? So how do we say 17 more than 3 times a number? Well, we say 3 times a number. We don't know what the number is, so it's 3x. But 17 more than that, so more than that by 17. 3x plus 17 equals 2. Now, which one of those answers is correct? Well, just take a look and you'll see that it is right there. Okay, here we go. Another problem says, at a graduation dinner, an equal number of guests was seated at each of 6 large tables. Okay, equal number of guests. Hang on, I got to change my pen size here. Back down to about right there. It says an equal number of guests was seated at each of 6 large tables, and 10 late arriving guests were seated at a smaller table. So let's see. Okay, I could draw out a picture, but let's just keep going. There were 82 guests in all. 82 guests in all. If n represents the number of people seated at each of the large tables, okay, so n is the large tables, what equation could you use to find the value of n? Okay, well, an equal number of guests was seated at each of 6 large tables. Okay, and we don't know what that equal number is. It might have been 12 people, it might have been 8 people, it might have been 2 people, it might have been 27 people. We don't know, but we know there were 6 tables and they all had the same number of people at each table. So n is the number of people. So if we take 6 large tables and multiply it by however many people are sitting on each table, that's multiplication. And then we add the late arriving guests. There's 10 of them. It doesn't say how they were seated. They were just seated at a small table. It doesn't matter. So this is the number of guests at the big tables. This is the number of guests at the small table, and that has to be equal to the total number of guests. Okay, can we see that now? Does that make sense? I sure hope so. And we see that B is the answer. All right, let's keep going. Question 4 says you buy 1.35 pounds of apples and 1.45 pounds of bananas. Apples and bananas sell for the same price per pound. Same price per pound. The total cost after using a 55 cents off coupon is $2.53. Now there's that word again, is. What does that mean in math? That means equal. And it is $2.53. So whatever we write down, it has to be equal to $2.53. Okay. So we're paying some amount of money for the apples and bananas, and whatever that number is, it's the same for the apples and the bananas. So if we do a real quick side math here and do 1.35 plus 1.45, that's a total number of pounds of fruit that we're buying, apples and bananas. We're going to get 10, carry the 1, 7, 8, 2. We're going to get 2.80 or 2.8 pounds of fruit. Okay? 2.8 pounds of fruit. We don't know how much we're paying per pound, but whatever it is, it's just, you know, it is whatever it is. How much are we paying per pound? Let's say, whatever it is, it's C. And whatever that price is, we're going to subtract 55 cents. Not per pound, just total, 55 cents. So we don't have to multiply by C. And so, here, let me change my pen color. Here is the price we are paying for all of our fruit, 2.8 pounds times the number of pounds. Then we're subtracting 55 cents, and it equals the total cost. So now just look for the match. What do you think? Can you spot the answer? I think it's going to be A. Can you explain why the answer is not E? Why is it not E? Think about that for a minute. All right, we're getting there, boys and girls. Question 5. It says, we want to buy a pet, hang on one second, lizard that costs $45. Lizard costs $45. You already have $15, so you have $15, and you plan to save $8 per week. If W represents the number of weeks until you have enough money to buy the lizard, what equation could you use to find the value of W? Explain how you could set up an equation to find the amount of money you should save each week if you want to buy the lizard in 6 weeks. Okay, so we have $45. Okay, we have, oops, I'm not sure what just happened there. We have $45. And we are saving, which means we're adding to that. Oh, no, my bad. Let me go back. How much do we have? We have $15, my bad. And we are planning to add to that or save $8 per week. Per means multiply. So 8 times the number of weeks that we save will be the total that we save. So let's go over that quickly again. This is how much I have. This is how much I am saving. And total, that will be equal to, hopefully, $45. That's the equation. Okay? So we choose our answer, 15 plus 8W or 8W plus 15. Don't forget it can go either way because of the associative property. It looks like that one right there, E. Now, the next question, hang on one second. Okay, well the next question said, if you want to buy the lizard in 6 weeks, explain how you could set up an equation. So how could you do that? This will tell you how many, this right here will tell you how many weeks you need to save to afford the lizard, and you can see that it was only take about 4 weeks. But if we want to take a little longer, 6 weeks, how could we figure out how much money we need to save? Well, you can see that if you subtract 15 from both sides of the equation, we know that 8 times the number of weeks has to equal 30, and we know W is going to be, well, it's going to be 3.75, so 3 3/4 weeks. If we want to take 6 weeks, then we don't have to use the 8. We're trying to figure out how much money we'd spend. So it would be 6 times 6 would have to go into 30, and so we could just save $5 a week. Okay, moving. Okay, this one says, in a certain country, the life expectancy of a woman born in 1999 was 82.1 years. I'm going to highlight that. A woman in 1999, 82.1 years. In 2009, the life expectancy was 0.5 years greater, so it went up. If L represents the life expectancy of a woman born in 2009, what equation could you use to find the value of L? Could 2 different equations be used? Explain your reasoning. Okay. Okay, so we're talking about 2009, it was, okay, and 1999 was 82.1. So if L represents the life expectancy of a woman born in 2009, what equation could you use to find the value of L? So L L is the life expectancy of the woman born in 2009, which is 0.5 greater. So if we subtract that 0.5, that will be equal to the life expectancy of the woman born in 1999, which was 82.1. So there you go. Now, could 2 different equations be used? Let's think about that. Well, yes, but none of these answers are correct. None of these answers will work except for that one that matches the equation I just wrote down, which is this one. None of the others are the same. Okay, so let's think about that. Okay, last one, boys and girls. Let's get through this one real quick. It says a jar contains only pennies, nickels, dimes, and quarters. There are 22 pennies. 22 pennies. There are 25 25 dimes, and there are 14 quarters. The rest of the coins are nickels, and there are 81 coins in all. How many of the coins are not nickels? Well, that would be all of these, because we have 25 dimes, 14 quarters, 22 pennies, and the rest of the coins are nickels. So if we add up all of these coins in this column right here, we add these up. So 2 plus 5 is 7, plus 4 is 11, carry the 1, it's 3, 5, 6. We have 61 coins, and it says the rest of the coins are nickels, and there are 81, so 61 plus the nickels, actually we can call that n, right? 61 plus the number of nickels equals 81. 61 plus what equals 81? We know n is 20. Okay, so the thing is, the easy answer for the first question is how many of the coins are not nickels? Well, that's 61, because those are the pennies, dimes, and quarters. So put that in the answer. And then it says, which of these equations could you use to find the number of nickels? And it is B. You can see the number of nickels plus 61, that's all the other coins, equals 81. That's it. Good job, boys and girls. Good luck on your assignment.